They are small, often overlooked, yet crucial to the functionality of virtually every electronic device we use. Resistors, the unsung heroes of the electronics world, are found in everything from smartphones and laptops to televisions and even cars. They play a vital role in controlling the flow of electricity, ensuring that components receive the correct voltage and current to operate properly. Without resistors, our electronics would be prone to overheating, malfunctioning, or even complete failure. Imagine a world without resistors. Your phone's screen might be too bright to see, your headphones could blast music at deafening levels, or your car's headlights might flicker erratically. Resistors provide stability and predictability in circuits, allowing designers to fine-tune the performance of electronic devices with precision. From simple LED circuits to complex microprocessors, resistors are essential building blocks that enable our technology to function reliably. By understanding these colorful markings, you unlock a world of possibilities, enabling you to build, repair, and modify electronic devices with confidence and precision. So let's embark on a journey to demystify the language of resistors and empower you with the knowledge to navigate the fascinating world of electronics. Before we dive into the specifics of the color coding system, it's important to grasp the fundamental concept of resistance. Measured in ohms, resistance represents the opposition a material offers to the flow of electric current. A higher resistance value indicates a greater impediment to current flow, while a lower value signifies less opposition. Resistors are designed to provide specific resistance values, allowing engineers to control the flow of current within a circuit with great accuracy. The color bands on a resistor serve as a visual representation of its resistance value, encoding this crucial information in a compact and easily identifiable format. The most common type of resistor utilizes a 4-band color code, where each band represents a specific digit or multiplier. Starting from the band closest to one end of the resistor, the first 3 bands indicate the significant digits of the resistance value: black 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. The 4th band, separated slightly from the first 3, represents the multiplier, which determines the order of magnitude of the resistance value. For instance, black times 1, no multiplier; brown times 10, red times 100, orange times 1000, yellow times 10,000, green times 100,000, blue times 1 million, violet times 10 million. To illustrate, consider a resistor with the following color bands: brown, black, red, orange. Brown first band represents the digit 1. Black second band represents the digit 0. Orange fourth band represents a multiplier of times 1000. While the first 4 bands of a resistor's color code define its nominal resistance value, it's important to acknowledge that manufacturing processes aren't perfect. Resistors, like all manufactured components, have a certain degree of tolerance, which represents the permissible deviation from the stated resistance value. This tolerance is typically expressed as a percentage and is indicated by the 5th band on a resistor. The most common tolerance values and their corresponding colors are gold plus or minus 5%, silver plus or minus 10%, no band plus or minus 20%. For instance, a 100 ohm resistor with a gold tolerance band could have an actual resistance value anywhere between 95 ohms, 100 minus 5%, and 105 ohms, 100 plus 5%. Understanding tolerance is crucial when selecting resistors for your circuits. When deciphering the resistor color code, it's crucial to remember that the position of the bands is paramount. The color bands must be read in the correct order to determine the resistor's value accurately. To ensure you're reading the bands in the right sequence, identify the tolerance band first. This band, typically gold or silver, will be slightly separated from the other bands and will always be the furthest to the right. Once you've located the tolerance band, you can then read the remaining bands from left to right, starting with the band closest to the edge of the resistor. Confusing the order of the color bands is a common mistake, especially for beginners, and can lead to significant errors in identifying the resistor's value. By paying close attention to the band positions and reading them consistently from left to right, you can ensure accurate interpretation of the resistor color code and prevent potential mishaps in your electronic projects. While the resistor color code system is relatively straightforward, even seasoned electronics enthusiasts can make mistakes when interpreting these colorful bands. Let's explore some common pitfalls and discuss strategies to avoid them. Incorrect orientation. As mentioned earlier, reading the color bands in the wrong order is a frequent error, especially for beginners. Always identify the tolerance band, either gold or silver, first, and read the remaining bands from left to right, starting with the band closest to the resistor's edge. Poor lighting. Trying to decipher resistor color codes under dim lighting can lead to misinterpreting colors, particularly similar shades like brown and red or blue and violet. Always ensure you have adequate lighting to distinguish the colors accurately. Color blindness. Some individuals experience difficulty differentiating certain colors, which can pose challenges when reading resistor color codes. If you have color blindness, consider using a multimeter to measure the resistance directly, or seek assistance from someone who can accurately identify the colors. Worn-out bands. Over time, the color bands on resistors can fade or become worn, making it challenging to determine the correct colors. Resistors are ubiquitous in electronics, playing crucial roles in a vast array of applications. Their ability to limit current and divide voltage makes them indispensable components in countless circuits. Let's explore some real-world examples to illustrate their significance. LED circuits. Resistors are essential in LED circuits to limit the current flowing through the LED, preventing it from burning out. By carefully selecting the appropriate resistor value based on the LED's specifications and the supply voltage, you can ensure the LED operates within its safe operating range. Voltage dividers. Resistors can be configured as voltage dividers to create a lower voltage from a higher voltage source. This technique is commonly used in sensor circuits to scale down the sensor's output voltage to a level suitable for an analog-to-digital converter, ADC. Timing circuits, resistors, in conjunction with capacitors, form the foundation of timing circuits, which are used to generate delays, control the frequency of oscillators, and create time-based events. By adjusting the resistance and capacitance values, you can fine-tune the timing characteristics of the circuit. Pull-up and pull-down resistors. These resistors are used to ensure a digital input pin on a microcontroller or other integrated circuit, IC, is in a known state, either high or low, when no other signal is present. They prevent floating inputs, which can lead to unpredictable behavior. While this essay has provided a comprehensive introduction to resistor color codes, the world of electronics is vast and constantly evolving. There's always more to learn and explore to deepen your understanding and enhance your skills. Consider delving into topics such as surface mount resistors. These tiny resistors, commonly used in modern electronics, have a different marking system than traditional through-hole resistors. Learn about their codes and how to identify their values. Specialized resistors. Explore the various types of resistors beyond standard carbon film resistors, such as metal film, wire wound, and variable resistors, potentiometers. Understanding resistor color codes is a fundamental skill that opens doors to the exciting world of electronics. With this knowledge, you can confidently identify resistor values, select appropriate components for your projects, and troubleshoot circuits with greater ease. Don't be afraid to experiment, build, and tinker. The more you work with resistors and other electronic components, the more comfortable and proficient you'll become. Embrace the learning process, seek out new challenges, and never stop exploring the fascinating world of electronics. So, gather your tools, grab some resistors, and embark on your electronics adventure today.